The Amana colonies, nestled in the heartland of Iowa, a National Historic Landmark and major tourist attraction for those seeking a handcrafted escape to life's simpler times. While many visitors are attracted to the Amanas for its historic charm, quaint shops, and German-inspired cuisine, the Amana colonies remain a thriving agricultural community, surrounded by 26,000 acres of rich farmland, pasture, and timber. It was this very land that attracted Amana's early settlers in 1855. Over 150 years later, Amana's agricultural community continues to thrive. Today, Amana Farms is the largest contiguous farm operation in Iowa, comprised of 26,000 acres, 9 miles long by 5 miles wide.
Amana Farms is a very diversified farming operation. We have forestry operations, row crop, and cattle, both cow-calf and cattle feeding.
Beef production is one of the farm's key operations. Currently, over 4,000 head of cattle call Amana Farms home. With such a large beef production operation, a lot of waste is produced. And in 2006, the government passed legislation that regulated how waste nutrients from cattle and hog facilities was applied to farmland.
This made it necessary to haul the feedlot manure further away than what we had formerly had to, and also gave us a good reason to try to better utilize the nutrients that were in that cattle manure as opposed to purchasing so many commercial fertilizers.
The 4,000 cattle on Amana Farms creates 75 tons of waste each day. But instead of seeing the manure as simply waste, the team at Amana Farms began investigating a golden opportunity. The idea? Convert the waste into energy, using a concept called anaerobic digestion.
An anaerobic digester, for lack of a more sophisticated explanation, is a lot like a cow's stomach. Anaerobic digestion is what happens within the multi-chambered stomach of a cow.
And the byproduct of anaerobic digestion? Methane gas. Amana Farms would secure funding to construct a 1.6 million gallon anaerobic digester in hopes of producing green, renewable energy and quality fertilizer for Amana's large crop production operation.
Right now I'm standing on top of the digester reactor itself. Underneath me is approximately 1.6 million gallons of mixed waste streams. This is where the anaerobic bacteria attack the dry matter within the stream and break it down and turn it into CO2 and CH4, which is methane gas.
Methane is one of the most volatile greenhouse gases. We produce that methane, we burn it through industrial internal combustion engines and generate electricity. And the product that we then take out has almost the same fertilizer value and will not release that methane into the atmosphere.
The Amana project was one of the first projects that the Iowa Power Fund Board elected to invest in. And there were a number of reasons for that. This is a real opportunity to capitalize on some of Iowa's products that had previously been waste products, ranging from manure to other kinds of organic waste.
Here's how an anaerobic digester works. Cattle manure is transported to the digester, where it follows a 21-day path through the digester. Working like they do in a cow's stomach, anaerobic bacteria break down biodegradable material and in the process release CO2 and CH4, which is methane gas. The methane gas collects in an 18-inch gap between the waste material and the top of the digester. Pipes deliver the methane to 4 710 kilowatt generators used to produce 100% green electric power to the grid.
But we quickly found out that the materials we were putting in didn't produce the amount of gas that it would take consistently to run more than one engine. That was very disappointing.
Amana Farms would increase the anaerobic digester's environmental benefit by introducing off-farm substrates. Thanks to partnerships with Iowa State University and consulting firm Howard R. Green, Amana Farms secured access to organic waste streams from nearby industrial partners.
This new building is a new addition to the site. We just put this in finished it up in January of this year. What it does is give us the ability to store up to 8 different products. That way we've got 2 to 3 days of storage of everything that we're feeding and don't have any disruptions in the daily feed schedule.
It's a win-win partnership for Amana Farms and its industrial partners. The cost to transport the off-farm substrates to the digester is largely offset by the substrate producers. Therefore, there is both a financial and environmental benefit for Amana Farms in using off-farm substrates to power the digester. And by using off-farm substrates, Amana Farms is leading the way in anaerobic digester research, finding new and exciting ways to reuse organic waste streams. While electricity is one of the main benefits of the Amana digester, it's having a major impact on other areas of the farming operation.
Running all of our manure through the digester is a benefit, not easily measured because you can't really see it. But a liquid material goes on the soils much more evenly and more fluidly, with very even crops, look very good. And part of that is because of the type of material we're getting out of the digester.
In 2010, our corn yields exceeded the county average by 12 bushels per acre, and we essentially used very little commercial fertilizer to do that.
Some of this material is getting used 4 or 5 times, and some of that recycled stuff actually starts here with our corn and soybeans that we raise, and the byproducts after industry gets done, it's coming back, we feed it, we put it back on the ground, kind of a circle of life.
That's often where you find the sweet spot in terms of investment. It's where the environmental concerns meet the economic opportunity, and therefore you can actually create economic wealth, you can create jobs, and etc.
Just as the early settlers found an opportunity in the land so many years ago, the same holds true today. Take care of the land, and it will give back.